so we want to start off strong. So let's make sure we're getting all of our questions answered. And of course, if you need more help after class today, you need to come in during advisory or shoot me an email. We'll set up a time, come in after school, whatever we have to do to make sure you're prepared. So first question you asked me, problem number 8. We have so we solved all these equations with radicals in this group of sections. And one thing we had to remember when we were solving radical problems, first of all, we always wanted to isolate the radical, and then we had to take each side to a power to cancel it. Second thing, when you get to the end of one of these problems, what do you always have to do? Check it, because you might get answers that don't work. Now this time I have multiple radicals, but if I'm trying to get rid of them, this is a cube root. How would you cancel a cube root? Cube it. And if you cube one side, you cube the other. Now lucky for us, everything's under the cube root, so what happens is both of those cancel, and we're just left with 5x squared plus 6x plus 3 equals 4x squared plus x minus 1. So quadratic, so what do we need to do? Combine like terms, set it equal to 0. So if I subtract over that 4x squared, it gives me a 1x squared. Subtract over my x, so that's a 5x. Add over my 1. Because it's 1x squared, we can do the shortcut. Multiply to 4 and add to 5. Then set each of those equal to 0, and we get -4 and -1. Remember to check at this point. Do you guys know how to check? Yep. Plug them into the original. I'm not going to take the time to do that in class today, so I want to get as many of your questions answered as possible. If you do check, both of these answers work. So that is our final answer. Question number 9. This is the one I did change from what was originally on the study guide. So we have a radical in here. First step is to isolate that radical. So I need the radical on one side, everything without it on the other. Two ways of doing that: I can either subtract over my x and then divide by a negative, or I could add over my radical and add over my 1. So I'm just going to add this. And then I'll add a 1 to cancel that. So we get x plus 1 equals the square root of x plus 3. Okay, then to cancel a square root, take it to the second power. I think you mean the right thing, just said it wrong. Okay, how do you square? When we have that x plus 1 squared, what do you have to do? FOIL it. So that would give me x squared plus 2x plus 1. Over on the left, the square root and the square drop, and we just have x plus 3. So make sure you recognize when you will have to FOIL. You'll probably have that pop up on your test. Then it's a quadratic, so we set it equal to 0. So if I subtract over my x, subtract over my 3. When do you have to do the full box method? If I have a coefficient with that. We don't, so we can do the shortcut. So that breaks into x. What multiplies -2 and adds to +1? So if we set each of those equal to 0, we get x to be a -2, +1. Then you have to check. So you're plugging those in. Always do it in the original. What happens when you plug in a -2? You get -2 minus 1. So you get -3 equals -1. And that doesn't work. Then if we put in a 1, your 1 minus 2 equals -1, and that one does. So your only answer on this is x equals 1. Okay. You guys did not ask about 10 or 11. If we have time at the end, we might come back to those, but you'll probably have something like that on your test. Remember, those are both like a quadratic, so you can do box method with them. There's just a little extra solving at the end. So if you don't know how to do that, you might, if we have some time at the end, ask me and I'll come back to it. So next question we had was number 12. Okay, this one is a little bit uglier because we have multiple radicals in here. If we start off on the left, what would I need to do? Okay, if you square one side, you square the other. What happens is it will cancel that outside radical. So we have 2 square root of 7x plus 2 equals 3x plus 2. Okay. I still have a radical, so if I want to cancel that, we square. Now over here, you have to, when I say square it, it means you have 2 of them. So if I take 2 times 2, we get a 4. When I take the square root of 7x plus 2 times the square root of 7x plus 2, the square root cancels, and you just get a 7x plus 2. So we have 4 times 7x plus 2. On the right, that means there are 2 of these, so you have to FOIL. So 3x times 3x would be 9x squared plus 6x plus 6x, so that'll be a 12x plus 4. Okay, quadratics, always set them equal to 0. So first we'll distribute our 4 and then we'll bring everything over. So if I subtract over that 28x, subtract over that 8. Now what? Box method. Can we do the shortcut? No. So we have a 9x squared, -4. So these two things multiply to -36, and they need to add to -16. -18, +2. So factor, we get 9x and 2, x -2. Set each of those to 0, so you get -2/9. And +2. What do we have to do at this point? Check. If you plug those in, they do both work this time. So I'm not going to take the time to do that. You can do it on your calculator. Just know that if there's an answer that doesn't work and you don't mark it off, you lose a point there. So make sure you are taking that time to check. Is that one all right? Let's talk about the graphing. Okay, when we graph exponentials, I told you to make a t-chart, and what 3 numbers do you plug in?
0, 1, and 8.
Okay, 2 to the -1 would be 1/2. A negative power just flips it. Anything to the 0 power is
1.
and then 2 to the first is 2. So I have -1 1/2, 0 1, 1, 2. When you graph these, remember, will it ever equal 0? No, you have a horizontal asymptote at 0, and it is a curve, not just a straight line. You can always use your graphing calculator to double check that you have the right shape, but I will be looking for those 3 points on your graph. So make sure you're plotting at least the 3 points, and then if you just want to check yourself, you could use the calculator. So if I did 1/2 to the x, what's 1/2 to the negative 1? 2, because it flips it. 1/2 to the 0 would just be 1, and 1/2 to the first is 1/2. 1, 2, 0, 1, 1/2. So what changed is that one is decreasing. You still have an asymptote at 0. Okay. So then we had if I gave you this one on the test, I would ask you to do a parent function and a transformation. So my parent function is just that 2 to the x, which we already graphed. Negative 1, 1/2, 0, 1, 1, 2. So there's our parent, which we always make dashed. What will this minus 3 do to my graph? When you go down 3, you have to draw in your new asymptote, because not only is it moving the points, it's moving our horizontal asymptote. It was at 0, so it drops down to negative 3. That happens anytime you move up or down. You have to move that asymptote. Left and right movements won't change it. So then you drop each of your points down 3. And we'll get our graph. The last one. So start with the parent function, which we already graphed. Negative 1, 2, 0, 1, 1, 1/2. What's the transformation this time? Left 2. So will my asymptote move? No. So our graph looks something like that. So on graphing those exponentials, you just have to remember the 3 points and then transformations. Okay, inverses, questions 16 and 17. I'm going to tell you right now, there will be probably 2 problems like this on your test. Those can be worth, like especially problem 17 where there's a little more work, these are worth like up to 8 points for a problem. So these are not good problems to just not know how to do. Okay, you want to make sure you know how to find these inverses, the domains and ranges. There's a lot involved. They're high point values. There's going to be more than one on the test. So this is not something to just say, it doesn't matter, I'll just skip those. Okay, you have to know how to do them. So on 17, this is one of the uglier ones because it has more than one x in it. So 16 only had one x, it wasn't so bad. This one's going to be a little bit uglier. What are the steps for finding the inverse? The first thing we do, f of x becomes a y. Then what do we do? So this y becomes an x, and every x becomes a y. Now what do we have to do? We want to solve for y. We have to get that y by itself. So we need to get rid of our fraction. To do that, you always multiply by your denominator. So these cancel. Over here, if we distribute, we get xy minus x equals y plus 2. I'm trying to solve for y, but we have 2 of them. So what do I do with those? I need them on the same side. So I'll subtract over this y, and then we'll just add over this x and move it out of the way. Then what? Yeah. We want to solve for that y. Before we divide, we need something, just one term over here. So if we pull out the y, that leaves us with x minus 1. So then to get y by itself, we divide. Final step, instead of y, what do we write? F to the negative 1 of x. Okay, then I'm going to ask you domains and ranges. And you have to label. You can't just put D equals and R equals, because there's 4 things I asked for. Domain of the function, range of the function. Domain of the inverse, range of the inverse. We know the domain of the function is equal to the range in the inverse. And we know the range of the function equals the domain in the inverse. So, domain of the function, look back at the original. It was a fraction. We know that if we have a fraction, what can't happen? So what can x not be? So we would have negative infinity to 1, union 1 to infinity. Okay, range of the function is equal to the domain and the inverse. If you look at the inverse, what can x not be? 1. So this one turns out to be the same. What if you didn't have a fraction, or you had a fraction and the denominator was just like a 5? If you don't have a fraction or the bottom's never 0, what would your domain be? Negative infinity to positive infinity.
That's if you don't have what?
If I give you, like, let's say your original function was that. So it's just a polynomial, so that domain would be negative infinity to positive infinity. If you found the inverse of this one, so if we switch x and y, so subtract 1, divide by 5. So in your inverse, we have a fraction, but the denominator is just 5. So what's the domain of that one? Yeah, so in this one, the original, there was no fraction, so it's a negative infinity to a positive infinity. The inverse, we have a fraction, but it's just a number, it can't be 0, so it's also negative infinity to positive infinity. Other questions on finding the inverses? Then we got into these common base problems. So you will have some of these equations on your test. And looks like we're going to be talking about a lot of these, so that's good. It's been a little bit since we did those. Okay, our strategy is to write these things with a common base, if we can. So if I am looking at this, what could my common base be for 16 and 64? 4. Did anybody take it down to a 2? Okay. This one there are actually 2 possibilities. You can do a 2 or a 4. It won't matter a bit. So let's say I heard more people say 4, so I'll go with that. 64 is 4 to the 3rd. And 16 is 4 to the 2nd. If you went down to a 2, you would have 2 to the 6th. And a 2 to the 4th. So either way, we're going to get there. Okay, when you have a power to a power, what do you do with those exponents? Multiply. Alright, biggest problem I've seen in answering questions, like problem number 18, you have to do this. You can't drop your base until you only have one of them on each side. So like 18, you break them down to a 2, but on that left-hand side, you have 2 of them. You have to put those together before you drop your bases. I only have one on each side, so we can set the exponents equal. So we get negative 16 over 9. Nice thing about these, they're very easy to check. You just plug them back in the original and see if it works. Okay, number 20. We have talked about going back and forth between radical form and exponential form in this group of sections. We want a common base. We can't break down this 3. So our hope is to write this one with a base of 3. A square root. So we have x squared plus x equals 1/2. Then what do you want to do? Okay, from here, a lot of you didn't like that 1/2. If you wanted to get rid of it, you could multiply everything by 2. And we would try box method. Unfortunately, is there anything that multiplies to a negative 2 and adds to a positive 2? So if you can't factor nicely, what have we done? All year, when things don't factor nicely, how do we solve them? Quadratic formula. And that hasn't gone away, we can still use it. Opposite of b would be a negative 2 plus or minus the square root of b squared minus 4 times a times c all over 2a. So I get 8 plus, oh no, that's 2 squared. So 4 plus 8, so a 12. How would I break down the square root of 12? So that's negative 2 plus or minus the square root of 4 is a 2. Could divide everything by 2. And that's about as nice as it's going to get. So that one was exceptionally ugly because it didn't factor nicely, but we could still handle it. Okay. Let's keep working on these. 22. Okay, our strategy is a common base. Can you break down 2/3? No, so we're going to leave that. Which means I need to somehow write this one as a 2/3. First of all, I notice 81 is 3 to a power. And 16 is 2 to a power. Make sure you're paying attention to me right now. We really want it to be a 2/3. So first of all, what kind of power would flip that? A negative. Okay, 2 to what power equals 16? 4. And is 3 to the 4th 81? Yeah, so this is a -4 power. When we have a power to a power, what do we do with those? Multiply. Now we have the same base on each side, so you can set your exponents equal. So if I add over my 4x, it'll be a 5x. Add my 1. Divide and we get a -3/5.
So how did you get -4?
So when I was looking at this, I first realized that I wanted my power of 2 to be on top, so I needed to think of it as 16/81, which meant my exponent had to be a negative. Then I tried to figure out 2 to what power would equal 16. And that was a 4. And then I checked 3 to the 4th is 81.
Yeah, that makes sense.
Okay. Then we got into the inequalities. When I taught you the inequalities, I said it's the exact same as the equations as long as the base is bigger than 1. So I always need to make sure that I'm choosing a base that's greater than 1 when I do these. Alright, 32 and 16, those are both powers of what? 2. So 32 would be 2 to the 5th. And 16 is 2 to the So power to a power, we so this would become a 4 minus 4x. Don't forget to distribute. My base is bigger than 1, 2 is bigger than 1, so we just set our exponents equal. So add over my 4x, divide by 9. The one thing that you do need to do is then write it in interval notation. So x is less than the 4/9, so it's everything smaller. So it'd be negative infinity to 4/9 equal to tells me I need a bracket. Alright, another radical one. You can expect me to give you something where you have to go back and forth between radicals and exponentials. You know, we used them here. We've also solved problems where I would say something like x to the 3/4 power equals, how about 8? If I gave you something like this, how did we solve those? Right, the denominator is what goes outside. So we had these on the last quiz. Do you guys remember how to solve them? What would you do? It's the fourth root, so to cancel it, you do the fourth power. What is 8 to the fourth? You guys help me out. The 4,096. Then how do you get rid of a cube? Do you need plus or minus? No. When do you have to put plus or minus? Right, an even root. And what's the cube root of 4,096? And so that would be our final answer. So we've solved some like this. I didn't have one exactly like that on the study guide, but we did have them on the last quiz, so it could very easily pop up on the test. So on this one started with the radical, and we need to write it the other way. So a cube root would be written as a 1/3 power. Okay, remember, I want to write these, if it's an inequality, I need my base to be bigger than 1, which 5 is. That means I really need to get rid of the 1/5. I would write that as 5 to the -1. So that gives me 5 to the -1/3 x is less than 5 to the -x minus 2. So then you can drop your base. Add over my x, divide by 2/3. Remember, if it's an inequality, if you divide by a negative, you have to flip it. Not the case for a positive. And you get x is less than -3. So how would I write that with an interval?
-3 to -3, and no fraction is not equal.
Exactly. Okay. Problem number 25, the last one of these. Can you break down 5/3? No, so it has to stay. It's an inequality, so we want the base to be bigger than 1, but 5/3 is, so I don't need to flip that. Okay, so I need this one to be 5/3. If I want the 5 on top, what kind of power does it need to be? A negative, and it would be a 2. 5 squared is 25, 3 squared is 9. So power to a power we multiply. So it gives me a -2 plus 10x. Drop your base. So if I subtract my 10x, divide by a -9, which will flip it. So less than or equal to 2 9ths would be -infinity to 2 9ths. Equal to means it gets a bracket. Let's talk about the interest problems. Are you guys good with the exponential equations and inequalities? So 26, we have 2 plans we have to look at. Okay, we have $40,000. So that is what? It's what you have right now to invest. So that's your P for both plans. To be invested for 3 years, so time always has to be in years, and that is. Plan A is 0.5%, so what do we use for the rate? always move it back 2 places, 0.005. And compounded quarterly, so that would be 4 times a year. We want to know which one would be the better option, so we need to find our ending amount. Formula, I told you I would give you. We don't know our A, P is 40,000. 1 plus R over N to the N times T power. And then you plug all of that in. So for the sake of time, I'm just going to tell you, make sure, this is money, so make sure you're using a dollar sign, 2 decimal places. So we get that. Plan B is 0.4%, so the rate would be 0.004. Compounded continuously. When you see continuously, what does that mean? Yep. So if we plug in, put all of it, just plug in your calculator. Okay, now we have to decide which one we're going to pick. So, is this a loan that we have to pay back, or is this money that we're investing? We're investing. So that means we want to make as much as possible, right? So we want the higher dollar amount. So the plan I should pick is plan A. Now, if you were borrowing money, you would want the lowest dollar amount because you don't want to have to pay back any more than necessary. 27. In 72 months, so my time is not 72, what would we have to do to that? Divide
6.
12. Yep. 12 months in years, so that's 6. You must have $12,000, so that's what we need in the future, so that is my A. My rate is 1.7%, so 0.017, compounded monthly, so N equals 12. We are looking for P here. So to solve this, we're going to just divide by that whole thing. Putting it all just directly in your calculator. And you get $10,837.14. Okay, we've got a few minutes, so I want to go back, things that we have not talked about. So the first 4 questions, where you have to change it out of radical form and into exponential form to simplify, are we okay with those? So like number 1, x to the 1/3 over x to the 1/2. And if you're dividing, what do you do with your exponents? Subtract them, so you should get x, or 1 over x to the 1/6. You guys get that? Number 2, you should get 1 over y to the 3/4. Number 3 should be x to the 7/6 power. Number 4 is z to the 11/6 power. Do we need to talk about any of those?
Can you do 3?
Yep. Okay. This entire thing is under a square root. A square root is what kind of power? 1/2. So instead of that square root, I write a 1/2. Then underneath it, I have an x squared times the cube root of x. That would be x to the 1/3. You guys know how to go back and forth between those? If these are multiplied, what do we do with the exponents? Add them. So 2 plus 1/3. And then we have a power to a power, which means multiply. Number 5, the domain. If it's an even radical, we know the thing underneath has to be greater than or equal to 0, so you should get bracket -2 comma infinity. Number 6, it's an odd, which means if it's an odd root, it can be anything underneath, so that one should be -infinity to infinity. Are we okay on those domains? Okay. We did an inverse problem. What about number 11? So 10 and 11 are both like this. They're not exactly like a quadratic, but we could treat them like one. We can do box method. We have to set it equal to 0. What multiplies to a -12 and adds to a +1? And each of those get an x to the -1. So when I factor out, we get 3x to the -1 and 2, 2x to the -1 and -1. Okay, at this point, we set each of these to 0. When we had the quiz on this, we had some problems here. If you're solving this, you would subtract over your 2. 3x to the -1, how would I rewrite that? The 3, that negative isn't applying to the 3, so it's just a 3 over x. That's the problem I saw, is most people drop the 3 down as well. So it's only the x that goes to the bottom. Then we can just multiply by x on each side. Divide by -2, and you get -3 halves. The other one, 2x to the -1 minus 1. So how would I write 2x to the -1? 2 over x. Multiply your x, and you get x equals 2. And then, of course, check those. Is that one okay? One thing on problem 18. I know I helped some of you with this. We have to get a common base for these 3 numbers. What would that be? So we have 2 to the x plus 1, 2 cubed to the -x, and 2 squared. What do you do with those? Multiply them. Don't drop your base yet. Because if you dropped it too soon, you got confused. With these, when I multiply those, what do you do with your exponents? Add them. And then you can drop your base and solve from there. So make sure you put those together before you drop your base.
How did you get an x on the dot?
I don't know. That's supposed to be a 2. Thank you. You guys know what to expect on your test tomorrow?
Yeah.
So if you do need any more help,